The broadcast is now starting. All attendees are in listen-only mode.
Good morning. Welcome to today's SIGAL webinar. My name is Paul Gabriel. I am the Geoscience Data and Software Services Manager here in SIGAL UK. Today I'm going to be talking about Blueback Project Tracker, and the title of my webinar is My Data is There, but Where is it? Thank you everyone for signing up and attending. We've been running these webinars for the last few weeks. We've got a couple more, so please do sign up. Please do tell us what you'd like to see. We can add more. Let us know what products, tools you're interested in, and we can do more of these. If you'd like to find out any more, please contact your SIGAL account manager or email sales@sigal.com. The format of these sessions, these are short sessions, short coffee break sessions, 20 to 30 minutes in duration. We're recording this right now. You're going to get a copy of this recording via email after 24 hours. We're also going to upload the video to our YouTube channel. The format is I'm going to run through a few slides, introduce you to the scenario and Project Tracker. I'm then going to delve into a short live demo, and if we have time at the end, you can ask some questions. If you have any follow-up questions that we don't get time to answering in today's webinar, we will message you individually over email. So, what's today's summary situation? So, what we've got a dummy situation where we have a newly acquired asset. In this case, we have a single Petrel project containing some seismic data. What we want to find out using Project Tracker to scan and ingest this information is what seismic data do we have in the project? How do we look at this spatially using Project Tracker? And what else can we learn about it? Technically, this data is coming from the UK's National Data Repository, the NDR, and it's a seismic package from the 31st license round. So, I'm going to introduce you to what Project Tracker is. I'm going to talk you through how we go forward and scan a Petrel project and how you would do this in an enterprise environment, and also show you what seismic information we capture when we scan Petrel projects. So I'm going to first show you the results in the Tracker web, which is our website that we provide with every instance of Project Tracker, and I'll show you some seismic views. We're then going to look at what spatial data is captured, in this case in Arcgis Pro, but you can use another GIS program. And we're going to have a look at what and how we capture live seismic traces with Project Tracker. So, a quick tool summary. What is Project Tracker? So Project Tracker is a Petrel plugin for the Petrel Data Manager used to track and monitor an ever-changing Petrel network. What we do, once it's all set up, is that we scan Petrel projects and analyze this data. And we can analyze it against Studio repositories too. The data is stored in an SQL database, and once it's in that SQL database, we then derive insight about the Petrel and Studio environment using Tracker Web, which is a locally installed web server that fires up a website showcasing this information. We're going to have a look too at how we ingest this data spatially, because we capture some spatial geometries. And you can also take the data from your SQL database into a BI tool such as Power BI, Spotfire, Tableau. Because we're deriving this insight, we're able to monitor the Petrel environment over time, allowing us to implement data management policies and procedures. So let me jump in to the demo. So, Project Tracker, this is Tracker Admin. Tracker Admin is the front-end configuration console for all our tracker scans. So we have to configure this setup to point to our Petrel instance, connect to our databases, and we point it to the Petrel projects that we want to scan. In my example, I've already gone ahead and pre-configured everything. So in this case, I have a single Petrel project, which is sat on a Windows file share locally to this machine. This is my project. Inside the project, I have some seismic, and that looks like this. This is my Petrel project with my seismic in it. So I've already gone ahead and pre-configured my tracker administrator to point to this Petrel project. This is my project here. I then select what data types I would like to scan. I've selected them all. In reality, I don't have all these data types. I'm really focused on the seismic. On the right-hand side here, you can see we're able to capture spatial data, and this is going to be important when we come and look at this later in Arcgis. The way this works is as the tracker goes and scans the Petrel project, and the way it's doing that, it's opening the project silently, and you can run this as a scheduled task to run across an enterprise Petrel environment. As it's scanning, it opens up the project silently and starts ingesting metadata about the Petrel data items. For the spatial data, we're building simple geometries that go and are stored in the SQL database, which we can then pull as query layers into other applications. You'll notice here that there is a toggle switch for projects. I'll come on to what that is a bit later because there's no such thing as a project boundary box in Petrel. The other thing to note just while we're here is we're storing all this spatial information in WGS84 in the database, and that allows us to map a Petrel environment on a global scale. So it allows us to take data that's in a local coordinate reference system, so long as the coordinate reference, so long as that project has a coordinate reference system, we transform to WGS84, and then we can project onto a globe. So you have North American assets on a map, on the same map as some assets in North Africa or New Zealand. So I've gone ahead and configured it all. I would then run the scan, and in that case, I would perform a scan and analyze, and that then runs Petrel silently, opens the project silently, and ingests the data. So I've already gone, for the purposes of time, I've already gone and done that, and the project that I have is in my SQL database, in my tracker database. So let's have a look now at the tracker website, where I'll show you how that project exists in the tracker website and show you and talk to you about some of these seismic views that we capture. So here you have my internet browser. I've got Chrome up here. I have my web server locally in an enterprise environment. The web server would be hosted centrally with users able to connect straight to the website, browsing your tracker, browsing your Petrel environment across an organization. So here we only have a single Petrel project, and this is my Petrel project here, Asset X. We're going to be focused on the seismic views only for today. So I'm going to click the seismic toggle here, and you can see that we have 3 different views. We'll start with bulk files. Bulk files is a higher level, simple view of the seismic files that are inside the Petrel project. So you can see here I have my Petrel project. I have my cubes. This name is the name of the cube. Data type, seismic cube or 2D. So it's a 3D or 2D. Storage type, is it SegY or ZGY? Bulk value type, the sample rate. File exists is an extremely useful attribute. What this is saying is, does the machine that performs the scan have access to the seismic file path from the Petrel project? So typically in an enterprise environment, a file exists is false would signify that the machine that is running the scanning is not able to touch this seismic file. And that can happen if a user locally realizes a seismic volume that would be disconnected, and you would have your seismic disconnected from that application server and potentially from other users. We have the file size and the seismic file path. Where is that seismic stored? So this is a pretty basic overview of the seismic data. If we move next to this seismic data tab, this was introduced in Tracker 6.4. If I turn some of these columns off, you'll begin to see that we're capturing additional metadata. So now we have the name of the file, the survey name, where is that file in terms of the bulk file path, but we're capturing more, and we're capturing information from the object settings itself. So we can see the inline increment step. We can see information about the studio business project it's connected to. We can see comments, which are the comments from the object itself. So this is, in this case, I have some of an obsidic in the comments. I have some information about how this ZGY was merged. So we're capturing a lot more information, a lot more metadata. It's a lot richer, and we can bring this information in spatially when we have a look at that in the Arcgis project. The duplicates view. This just needs a little bit of an explanation as to what you're seeing. The way that we generate duplicates is we run a analysis on the seismic files, and we group files of similar size together. If we have these groups, we then take the data that's in those groups and we run a hash code. We generate a hash code on those files, and we then look at the hash codes. So to put it another way, in this case, in my Petrel project, I have 2 copies of the same file. So I have this file here and this file here stored as 2 separate files, yet they both have the same hash code. And so you can imagine this is one of the most powerful functions that Tracker provides. If you run this over an enterprise Petrel environment and generate these hash codes, you can then begin to see the true seismic duplication that exists within an environment. And that is extremely valuable to help save space and just be tidy. Okay, I'm going to now jump into looking at this data spatially. So to do that, I'm going to jump into Arcgis Pro. And here I have my Arcgis Pro project. And I mentioned when I was configuring the Tracker admin scanning that we capture these simple geometries around data objects in the Petrel project. And one of the objects that I said we capture is this project boundary. The way that works is we create a bounding box around all these geometries apart from the polygons. And the reason for that is that you can have sometimes shape files in a Petrel project which are very large, and you don't want to be creating boxes around that. So it's everything minus these polygons. And what that is stored inside the SQL databases. It's technically SQL geography types. We streamed them in as SQL query layers, so it's a live connection here in my Arcgis project. It's a live connection. So as the tracker environment is scanned and updated, the query is updated and my project here changes. So we have the different data types. If we look at, in this case, look at my spatial project, this is my bounding box. So the data objects I have inside my Petrel project are bounded. They're in this polygon, basically. So let's dive into this area and have a look further. So by default, we have different views that we can bring in. We're going to be focused on seismic only. So in terms of seismic, we have a cube view, so geometry around these cubes, and that's what you're seeing here. So this is a simple view of my cubes. There is some additional attributes provided with this view, and we can see those looking at the attribute table. So you can see the GUID, what project it's connected to, the name of the file, what survey, the last modified date, and some information about the shapes themselves. You can go and query as you like, but if you remember when I was showing you the tracker website, we had that second view, which was seismic data with detailed information. We can incorporate that additional information into this too. And that's what I've done here. So now we have the same seismic data, same spatial information, but coupled to additional attributes. Technically, there's different ways you can do this. You can do it as a custom view in the SQL database, or you can do it here inside Arcgis Pro, or whichever GIS application you use. But you can see that we're capturing much more information, enriching the value of this spatial information. You can incorporate this information, bringing these SQL query layers, this spatial information from Tracker as part of the Petrel environment. One of the big benefits of bringing this in is being able to incorporate it into your own enterprise spatial data sets, your GIS information. So I've got a few examples of integrating it into a few other to just make this kind of analysis a bit richer. The first one, I've got some in my Petrel objects, I have some comments, and I've brought those into the pop-ups. So what you have here is this is my seismic cube, and I've got these are the comments from the Petrel object themselves, and I can delve into here and have a look at the different comments that exist on that Petrel object. So here I've got some information about how this ZGY file was merged, and you can see it's just some plain text from the comments. Another one, got the beginning of an obsidic header. So you can incorporate different data sets from the tracker database and deliver that spatially. One of the other things I wanted to show you is an example of connecting and hyperlinking different documents and doing that spatially. So here we have an example of some cubes where I've attached the URL to the Petrel project from the tracker website. So if I click this link, it takes me back to Tracker Web, and here I have some overview information about the Petrel project that this seismic is coming from. So I have some base level information, the history, where is the project, some basic file size information, what is the coordinate reference system, the history of the project, when it was created, saved, what seismic files exist in that project, and that kind of thing. I also have hyperlinked the acquisition report, pretty straightforward stuff, but you can see how you can build this up into a nice enterprise solution. I also did a little novel idea here of taking a few time slices from the Petrel project and hyperlinking those here in as well. But we'll come on to live seismic traces later. So the final thing I wanted to show you is how we generate live seismic traces around these cubes. So we're building polygons around the data. So we're looking for dead traces, and we use a image-based algorithm which always works. It can generate multi-part polygons, so you can have islands. There's different ways to do this. I'm going to show you both ways, starting out first of all with looking at it in Tracker Admin. So Tracker Admin was the configuration console that I showed you at the beginning. On the left-hand side, you have different modules. At the bottom, you have these. You have this live seismic traces module. So if I select that, what you see here is a list of all the seismic files that are inside this database. Obviously, I've only got one project and only a few seismic files. And what you can do here is you can select a particular seismic volume, validate, and run the boundary generation. The way this works, it runs Petrel silently, generating these live seismic traces, and you can do this in batch. So you can run this in batch, allowing you to do many boundaries all at the same time. If I show you what that looks like spatially, let's turn this bad boy on. So we have two cubes here. This is the cube geometry that we capture with the initial spatial scan, but now let's put on my live seismic traces. And you can see now that the dotted line is the extents of the seismic, the live traces themselves. In other words, outside of this dotted line on this green line, these are what we consider as dead traces. And if we compare this green polygon with an image of what the cube looks like, just a time slice, you can see it kind of matches up nicely. So that's how we run the live seismic traces using Tracker Admin. We can also run a more local process of the live seismic traces, and we can do that in Petrel itself. The way we do that is like this. So I have this is my original cube. Just to make it more of a challenge, I've gone ahead and cut this particular cube you're seeing to a polygon. And in that case, I have the Segal logo. This guy is called Chip. I've gone ahead and used the cut seismic function in the Blueback toolbox to crop this cube to this polygon, which gives me something like this. And then I've gone forward and performed live seismic traces on both volumes. And the way you do that, you simply connect this Petrel instance to your tracker database and the tracker configuration. And you do that in the data management monitoring function here. Once you've done that, you right click and simply select make tracker cube boundary. That then runs the process from this Petrel instance, running the image processing and pushing that spatial information to the SQL database. If we jump into Arcgis, if I jump to my final view, and turn that off. These are the two cubes, the original and the chip cut. And if I turn on my live seismic traces, you can see now the yellow polygon boundary is the chip cut that I did, and the blue dotted line is the initial live seismic trace outline. Once you have this information, this is also stored in the SQL database. You can do whatever you like with it. You could push it into your BI tools. You could do further spatial analysis here and calculate area of live data. The idea here is that you can integrate the cube with the live seismic trace in a really performant way. So that's all I wanted to show you. Thank you for watching. We'd love your feedback. Like I said at the beginning, please let us know what else you'd like to see. If you have any questions about what you've seen today or any of the Blueback tools, please email support.geo@segal.com. We have another video on Wednesday. This time it's on seismic reservoir characterization. Any questions? We have a few minutes where I can answer some questions. Thank you very much. And happy Easter. I have a question. Okay, is the seismic live trace confined to a certain Z level? So I can provide you with a full documentation, but the algorithm basically selects 3 inlines to analyze the vertical window where the amplitude values are varying or non-constant. If no trace values are found, because the cube has constant values, the extraction algorithm will look for areas where trace values are 0 and consider these as dead. This then creates an image representing areas of live traces as a time slice, and then this image is then processed to create this closed polygon. So it is kind of hard coded. It's not adjustable, but it looks at different inlines through the vertical window. Okay. 1 more minute. Any more questions? Okay, we'll leave it there for today. Thank you very much for your time. Please do let us know if you have any further questions. You can send those to support, and we will do our best to get back to you with the answers. Thank you very much, and have a good rest of your day. Thank you. Bye.